In this class, I'm going to explain an introduction to object-oriented programming with Java. So some of the key concepts with object-oriented programming in Java are abstraction, then the concept of class versus object, encapsulation, information hiding, where you want to hide data from users of your class. Then you have the concept of class methods versus instance methods, how you invoke instance methods with an instance of an object and how you invoke class methods with the class itself. And constructors are used to create an object of a class. So let's start with abstraction first. Abstraction basically it captures the important details of an object. You basically focus on what the class does but not how it does it. And generally you interact with the object of a class via the exposed public methods. And you invoking the methods, the public methods of a class is called as passing messages to the objects. And the what of a method is specified by the signature of the method. The signature of the method includes the data types and the order of the data types and what the method returns. And how is the body of the implement of the method, and that provides the implementation details. So when you are initially focusing on abstraction, you just want to specify the important public methods and how you interact with the object using those public methods. So a class is like a skeleton or a template or a blueprint of how objects of that class look like in terms of the data they contain and also in terms of the behavior that they expose. The behavior is the methods that the class exposes. And an object is a real live instance of a class. So when an object gets created, it has both state and identity. In Java, an object always occupies memory in the running JVM. And the identity is the address of the object in the memory. And state includes the value of the data members of all the data members of the object. And the state of the object keeps changing when we invoke the methods on that object. Encapsulation basically means how we encapsulate both the behavior and the data and the implementation details inside a class. The behavior is exposed via the public methods, and some of the methods could be private methods and they hide the implementation details. Usually data members are always private, they are hidden from external users. So the what, which is the public methods, are exposed, and how the implementation is done is hidden, and how includes usually the data and some private methods and some methods. Information hiding basically hides the data and implementation details which could be in the form of some other methods. So by using information hiding, you make your classes more cohesive, and this reduces the coupling between your classes. So ideally it makes your programs more robust and less error prone. And the way this is done in Java is by using access modifiers. So access modifiers control how access to the data and methods is controlled. So there are three kinds of access modifiers in Java: public, private, and protected. Public means it is globally accessible. Private means it's accessible only within the class. And protected means it's accessible within the class and all the classes which inherit from that class. And when you don't provide an access modifier, then that data or the method is accessible throughout the package of the containing class. And this is the default access. If you don't provide an access modifier, the default is everything in the package can access it. Everything in the package of the containing class. Then there are some methods which are provided called getters and setters in order to provide access to the data which is hidden. So if you have a private integer variable called x, then the getter is usually called as public int getx. It returns you the value of the x, and the setter which writes to this data is public setx, and the return type of this is void, usually is void because it's not returning anything, and you pass in a value of x which is used to set the internal data member which is of the same name. Constructors. Constructors are used to create an object of a class. They normally have the same name as a class name, and they are normally public so that users of the class can create an object of the class. And constructors don't have a return type, not even void, and they cannot be static. And the way you create an object of a class is by invoking the new operator. When you invoke the new operator, you pass the name of the class. In this case here it is person, and new basically allocates memory for the person object, and also invokes the constructor by passing these two arguments, and the constructor initializes the data members of the class of the object. So new basically allocates memory for the object of the class, and it initializes that object by calling the appropriate constructor. And constructors can be overloaded. That means you can have one constructor with different kinds of arguments in the method signature. And the constructor that gets called is the one that matches the data types of the arguments passed to the new operator. And constructors can be chained, meaning that one constructor can call another constructor. This helps to promote code reuse. And every class in Java inherits from what is called as the object class, and this inheritance is implicit. We'll cover about inheritance later when we talk about object relationships. And this object class has default implementations for some methods like ToString, equals, hashcode, wait, and notify. The ToString method provides a string representation of an object, and basically it overrides the default ToString method provided from the object class. Usually the ToString method is used to format the data of the object in a readable form, and if you use the ToString method in a context where a string is required, then it will then the Java will automatically invoke the ToString method of that class. And finally we have what is called as class versus instance level access. If a method or a data member is specified as a class member, then you have to use the keyword called static, and you invoke that method or access that data using the class name. For instance level access, there is no keyword in Java, and you always access an instance level method or a data member by using an object of the class. And the important difference between instance methods and class methods is that instance methods have access to this keyword, which represents the current object on which the instance method has been invoked. So let's look at an example of a program which shows most of these concepts. So here I have an employee class. If you look at this employee class, it has these attributes called name, SSN, email address, and year of birth. And if you see, all of them are private. That means you want to hide access to the data members. And then I have a set of getters and setters. So if you see the setters and getters, the setters return type is void and they are public. So you are exposing how you can set the name of this employee. And here, if you want to retrieve it, again it is public and it returns a string, and it returns the name. In the setters, if you see, there is an access to this keyword which represents the current object. So you are using this name to initialize the attribute called name, which you access by using this dot name, and you have to qualify it with this dot name because the name of the argument is the same as the name of the attribute. So you want to explicitly mention that the left hand side is the attribute of this class. Similarly, I have a setter and getter for the SSN, email address, and year of birth. Here I have an instance method called print employee, and it returns a void, and it just prints the name, SSN, year of birth, and email. And this instance method can only be invoked by an object of a class. And here I have a ToString method which returns me a string, and here I am showing that the name is this dot name, SSN is this dot SSN, year of birth, and email. And then finally I have a static method called print employee. This is a class level method. That's why you have the keyword static. And now you can invoke this particular print method, print employee, by using the name of the class, and the name of the class is employee. So let's look at an example program which uses this class. It's called as employee demo. And in the employee demo, first thing I do is I create an instance of this employee class called E1. Then I set the attributes of the employee, the name, the SSN, and the email address by using these setter methods. Similarly, I create an instance of another employee called E2. I set its data by calling the setter methods. Then to retrieve the data members, I use the getter methods, get name, get SSN, get email address, get year of birth, and so on. And I do this both for E1 and E2. And then here I assign an E1 to another employee called E3. Now both E3 and E1 are references to the same object, and so E3's name and E1's name will now be the same. And in this line, I invoke the instance method called print employee by using the E3 instance. Here I am printing the employee using the E2 instance. So both of them will have different values. Then finally here I am concatenating E3 to a string. Since here the plus operator requires a string on the right hand side, it will automatically call the ToString method of the employee object. And in this case it expects a string, so it will automatically invoke the ToString of the employee object of E2 objects. And then I can always call a class level method with the name of the class. See, when I call this print employee, I am passing an instance of this, but I am calling this with the name of the class. When I call a method with the name of the class, it is a class level method, and it is declared with a keyword called static that you see here. Whereas this print employee is an instance level print employee, so I have to call that with an instance of that object, which I am doing it over here. So I am calling this print employee with E3, I am calling this print employee with E2. Those are our instance level methods. So I have explained how you create a class, how you create an object of a class by invoking the constructor. Let me show you an example of in this class there is no constructor, it has the default constructor. So let me look at another class where we have a constructor. So for example, in this class I have a car class which has all these attributes: make, model, year, license plate number, color, speed. So the default constructor does not take any arguments, and it is just setting the speed to 0. But if I have a car where I have to initialize the make, model, year, license plate, then I use this constructor. I mentioned earlier that constructors can be overloaded, so you can have more than one constructor. And if you notice, the name of the constructor is the name of the class, which is the public car class, and the constructor does not have any return type, not even void. And also notice that in the constructor the first method should always be super. So if this class inherits from another class, you want to initialize the base class members, and after the super method, which is the first line of any constructor, you initialize the current class data members. And you always initialize the data members by explicitly using this before every attribute, because the name of the arguments could match the name of the attributes. And then you to create an instance of a car, you say new car and pass all the attributes. So new will allocate memory and initialize the data members. And then once this object of this class is created, I can invoke the ToString method in an implicit way by passing it to system.out.println, and I can also invoke messages on this object, instance level methods like accelerate or decelerate. So these are all instance methods. They have to be invoked with the object of the class. So this provides a basic introduction to object-oriented programming in Java.